Welcome to the masterclass on embedded C programming. I warmly welcome you to the session. Thanks for coming and thank you for your time. And today's topic is about pointers. Okay, we are going to discuss about pointers and the importance of stdint.h. Okay. So before we go into the topic in detail, I'll give a short introduction about Pantech and about me for 2 minutes, and then we can go for the session. So Pantech was started in the year 2004. Like, we basically manufacture microcontroller boards, DSP boards, and FPGA boards. Want to know more about our products and services, just log on to our website, pantechsolutions.net. Okay, our vision is to help 10 million students to learn the technology in an easy way. We have a lot of upcoming programs. We have upcoming programs on MATLAB, going to start next week for 30 days. And we also have upcoming programs on self-driving car, and software-defined radio. Okay, that's for 3 days. A 3-day workshop on self-driving car and 3-day workshop on a software-defined radio. So if you want to get notified about these sessions, like, please hit the subscribe button so that you will get notifications. Sometimes the email may land up to spam, and sometimes we may not send an email. So please do subscribe to the channel to get notifications. About me, my name is Jeeva. If you want to connect with me, you could connect me on LinkedIn. Hey, send me a connection request. I'm happy to connect and happy to help. And for those who have paid for the internship, like, we have an announcement, like, those who are paid for the internship, we have a hackathon session on this Saturday from 9:30 to 12:30. It's a 3-hour session for PCB design. So if you attend the session, like, you will be familiar with how to design a 2-layer PCB. So please do check your emails. You might get an invite of Zoom, and please do register for the event. It's free for those who enroll on internship. You will also get a mail. You will also get a detail about how to install the software Calends. Okay, and you will also find the link to download the software. So you could attend the session and you could get more benefits. And for getting the free e-certificate for this session, you need a minimum of 25 days of attendance. Okay, 25 days of attendance is required to get a free certificate. And attendance link, it will be available at the end of the session, or it may be at 9 p.m. So please do stay connected till the end. The learning is the key thing. Okay, so some sessions, like, it will be streaming a recorded video session, and PPT is shared on the Facebook group, as well as it will be shared on the Telegram group. And the winners, like, the pen drive has been shipped. Okay, so I'll be announcing the task today or tomorrow for the next pen drive task. So please do submit your assignments and connect your pen drives. Okay, let's go for the session. Let's start the day with a mindset lesson. Okay, today mindset lesson is about, this quote is from John D. Martini. And if you're not filling your day, okay, if you're not filling your day with a high priority actions, then the day will be automatically filled with a low priority distractions. Okay, so this is the quote which I love most. So you have to plan your day, else, like, it will be filled with the low priority task. Okay, so always plan your day ahead. Maybe before you're going to sleep, you plan for the next day. So so that you could take actions when you get up from the bed. Okay, so plan your day in advance. First, decide where to go. Like, decide your goal, where to go, and prepare an action list. Like, what are the steps you have to do, and plan your day effectively and take actions of that. Okay, so those who are success are action takers. If you're not going to take actions, then you're not going to succeed. You have to take actions, no matter whether it fails or whether it work out, no matter. But how you take is whether you take actions is what kind of effort you put is the thing which really matters. Okay, so plan your day, take actions. Ideas are worthless unless you act on it. Okay, so great ideas will not work until you work your ideas. So take actions on your plan. That's a key thing which I would like to share you today. Let's go for the session. So today class is about pointers. Okay, so pointer. So what are pointers? Okay, so pointer is a variable, like, it's a variable to store the address of another variable. Okay? As like the other variable, you have to declare these pointers. whenever you declare a variable, you'll be declaring the data type for that variable. Similarly, you have to declare the pointer variables. Okay? There's a You have the data type variable for the pointers, and you have to declare that pointer data type. You have the pointer data type for that. You have to declare the pointer data type. Okay, for that. So pointers are variables whose value is the address of another variable. Okay, so these are pointers. So pointers plays a major role on embedded system design. Okay, so how pointer works? Okay, you have this is the memory address. This is a memory memory locations of a computer memory or a microcontroller memory. So if the memory with this 8 bits, you are going to have a 8-bit data. Okay, and each memory will have an unique address. Each memory locations will have a unique address, where you could access those locations via this address. Okay, and this address is 64-bit if it is a 64-bit machine. If it is a 32-bit, if a 32-bit microcontroller, it would be 32-bit. If it is an 8-bit, it may be of 2 bytes. Okay, 2 bytes of address. So based on the microcontroller, the address size will vary. Okay, for a CPU, it's 64 bits, and for microcontroller with 32-bit microcontroller or microcontroller, it is 32 bits. Okay, so these are the data which is stored inside the locations. Okay, and this is the address. This is the address where you could access this data by using this address, and this address is unique for each and every locations. Okay, so pointers. So pointer variable contains these address. Okay? Pointer variable will contains these address. So by using this address, so these memory location addresses are called pointers. Okay. So you could perform operations like read operations by using pointers. You could perform a read operation, and you could perform a write operation, and you could increment and you could decrement the pointer variable. Okay, so these are the operations which you could perform on pointer variables. The pointer variables will contains the memory location of an variable, other variable. Okay, so these memory locations will be stored on the pointer variable. So I just repeat. So pointers are variables which stores the value of the address of the another variable. Okay. So as like the variable, it also has to be defined. You need to declare a pointer data type for this. Okay. So pointers plays a major role on embedded system design. So you could use pointers to store a data in memory, like flash memory or SRAM memory, or any type of memory. You could use pointers to store data, or to store data, or to read data, and you could configure the peripheral registers. Okay, via a pointer. So most of the peripheral registers, the peripherals are nothing but UART is a peripheral. Universal Asynchronous Receiver Transmitter is a peripheral, and SPI is a peripheral, I2C is a peripheral. So every peripheral will have a register, peripheral registers, and it will have a memory map. Each register will have a unique address in the memory map, in the microcontroller memory map. Okay, we will be covering up more details of the microcontroller memory map later, so don't need to worry about this. But as of now, you just remember like each peripheral registers will have a unique address on the MCU memory map. So these registers can be accessed via pointers efficiently. Okay, so pointers are used to configure the memory map and the memory map of the processor, and specific registers like interrupt registers and all kind of UART registers, SPI registers, I2C registers. All the registers can be accessed via pointers. So pointers plays a major role on embedded system. So you have to be get thorough on the pointer if you want to write the code for an embedded system. Okay, so these are the pointer data types. So it has an char and it has an asterisk symbol. Okay, so this is so sometimes so these are the pointer data types: char of asterisk and int, long int, float, double, unsigned char, unsigned int, and unsigned long int, unsigned float, and unsigned double. So these are the pointer data types. Okay, so if you want to define the pointer variable, like you have to declare the pointer data type here, and then the variable name. Okay, it looks like this. So char sometimes you could also use this asterisk symbol here. Okay, so you could also use this asterisk symbol. So it's called as dereferencing operator. Okay, so char of asterisk symbol, this address, and this is the address. Okay, and this is explicit casting. So if you check this variable, like char of address 1 and this storing the 8 bytes of data, if you check this variable, like this address 1 will have an address. Okay, this pointer variable will have a address, and this address in this pointer variable, it has an address. In this address you will have a value. Okay, you have a value which can be read, or which can be, you could read this value or you could write this value. So this is a pointer variable. The pointer variable will have an so this is the memory location. This is the address and this is the value. So pointer variable will have the memory location address. Okay, memory location pointer variable will store the memory location address, will be stored in here, and this address is the so pointer address. So every pointer variable will have an address. So that is this address. Okay. So the value stored on the pointer variable is another address. Okay. Address of another variable. So if whenever you declare a pointer variable, okay, like char or int or long int or double, it always reserves 8 bytes of memory. If you are going to use a 64-bit machine, okay, if it is a 32-bit machine, then it is going to use 4 bytes of memory, 4 bytes for the pointer variable, no matter whether it is char or int or long int or double, but it allocates 8 bytes of the pointer variable. Okay, so pointer data type does not control the memory size of the pointer variable. So you could declare a variable called char asterisk of address 1, and you could store a 32-bit address, okay, 32-bit address on it, or you could store a 64-bit address on it. Usually char will store only 8 only 1 byte, 8-bit, okay, 1 byte. But on in pointer, when you declare the pointer variable, it does not control the memory size of the pointer variable. Okay, so the purpose of mentioning this data type is so it can decide the behavior of the operations performed on the pointer variable. Okay, it could return the data. It could where I will cover you an example on the upcoming slides. Like it could control, or it could decide the behavior of the operations which is performed on the pointer variable, like read operations or write operations, increase or decrement, anything. So char or int determines the behavior of the operations. I'll show you an example on the next part. Okay. So for example, the read operation of address 1 by using char will be of 1 byte data. Okay. So the read operations of int will be of 4 bytes data, and the read operation of long int will give you 8 bits of data. Okay. So pointer variable of captured data. Okay. So if you want to perform a read operation of the pointer variable, then you have to dereference. Okay, you have this asterisk symbol is called a dereference operator. Like you have to dereference this variable to data. So this will read the data from the pointer. Okay, if you want to write, when you read the data from the pointer, like it will have the address 1. Like if this is the code, like it checks for the address, and this address has the value 85. So this value data will have the value 85. Okay, so this is the read operation of the pointer. I just repeat. So when you use the syntax like char data equal to dereference this address 1, this pointer variable. Address 1 is a pointer variable. When you dereference this pointer variable, like it checks for the address and takes a value which was stored on this address, that is 85, and it moves to the variable data. Okay. So this is a read operation of the pointer. So when you perform a read operation, like char will return like 1 byte of data. Okay. Whereas int, when you use int, it will return 4 bytes of data. When you perform a read operation, it returns 4 bytes of data. And long will return like 32, 8 bytes of data, 64 bits of data. So write operation, I'll show you an example, so it will be very clear for you once you go through the example. So write operation, so you just directly store the value, you dereference the address and store the value. It will write on this data. You write the value 89 to this pointer variable. Okay. So this is the example which we are going to cover up. Like we are going to create a char type variable, and first we are going to initialize the value of 100. Okay, and then we are going to print the address of the above variable. So, and then we are going to create a pointer variable and store the address of the above variable and perform the read operation, then write operation. Okay, and we are going to store value 65 and we are going to again check for the value. So let me copy this. Let me copy this one. I'm just opening Microsoft Edge, onlinegdb.com. Okay. So I have copied this. So first I choose this language. So these are the steps we are going to do. So the first thing is we are going to create a char type variable. Okay, we are going to create a char type variable and initialize the value to 0. So I will start with this. So first declare a char type variable called data. Okay, and I'm going to initialize the value as 100. Print the address of the above variable. Okay, so I'm just going to printf the address of data. Okay, the address of data. So I'm going to use the format specifier %x for hexadecimal. Okay, /n and this data. So we have to print the address. Okay, to print the address you have to use an ampersand sign to get the address of the variable and terminate this with semicolon. Okay. Hit the run button. Okay, so if you check now, the address is, this is the address which is getting printed on the console. Okay, so now print the address of the above variable, create a pointer variable and store the address of the above variable. So I'm going to create a pointer variable with char type. So this is the pointer data type. You could also use this, or you could also use this. So I will name it as pointer variable. Okay. You could also have the asterisk symbol here or here. Both are same. Okay. I'll just use this. Okay. So we have create a pointer variable and store the address of the variable to the above variable. So I'm going to store the address of the variable, pointer variable, ampersand of data. Okay, and perform the read operation of the pointer variable to fetch 1 byte of data from the pointer. Okay, perform the read operation of the pointer variable. So perform the read of pointer variable to fetch 1 byte. Okay, so read operations. So I declare a value called char value equals you dereference this pointer variable. Okay, to dereference the pointer variable. Okay, so I'm going to print this. Stored in the pointer variable. Okay, taking some time. So I will copy this to the IDE. I just go for file, new C++ project. Okay, C manageable. Click next. I'll choose this empty project. Choose min GW GCC example. Okay, example day 8. Click finish. Main.c. So I just paste this here. Right click, build project. Okay, and run as local C++ application. Okay, so now if you check the console here, the value of the content stored in the pointer variable is 100. Okay, so this is the read operation. So this is the read operation. Okay, so if you want to write operation, like you want to store a write so I will write operation. You want to store the data, use a pointer variable here, and I change the value to 60. Okay, now let me print the value of the data here, not the value here, it's data, pointer variable data. Okay, so if you check, so this is the write operation. So right click, build a project, go for run as local C++ application. So the data has been stored in the pointer variable is 60. Okay, so the online compiler is taking some time, so I'm going to use the STM32 cube compiler itself. So I just explain this code. We have declared a data. We have declared a variable called data 100, and we have declared a pointer variable, okay, of type char, and we have this ampersand symbol is used to get the address of this variable. Okay, and we have stored that in a pointer variable. So the pointer variable will always have address. Okay, pointer variable. So if you want to read the pointer variable, then you have to use this dereference operator. This asterisk symbol is dereference operator. So use this operator on the pointer variable, so it will get the value. It won't, the value will not have the address, it will have the content in the address. So the value will be 100. So that is print here. So that is a read operation. You perform the write operation to store some other value on that value, on the pointer variable, not the address. Here you are going to store on that location, memory location. Okay. So you have to dereference operator pointer variable asterisk of pointer variable equal to 60. So that prints 60. So this is an example for read operation and for write operation. Okay, let us check an example for how to increment and decrement the pointer variable. Okay. So I'll create another project, file new, C++ project, click C manage build, click next. Okay. Example, I will name it as example 7. Choose the compiler min.g.w.gcc, click finish. Okay. So choose this one file, go for new C source file, main.c. Okay. Okay. So the next up then is let us check for the let us check how an incremental how to increment the pointer, and how it works. Okay. So I just defined, let me check the PPT. Okay. So let's check for incrementing the value. So I just declare a data, okay, long of int data equals it's a 32. Okay. So it's a 8-bit data. So I just declare an 8-bit data of long int. So I'm just declaring first. I'll go with char. Okay, char of this address, declaring a variable. Okay, and I'm moving the address to this variable of data. So let us check the value stored, data stored in the address, data stored in the address. So I use the pointer variable. This is a format specific for pointer variable, and this is for the hexadecimal. Okay, /n. So I use this. This is the address. Okay, to get the data, I'll use this. This is printf. Build the project. Okay. So we got a warning here, like incompatible pointer type of long int to char. Okay. So you could do an explicit casting of I click and build the project. Okay. So the warning has gone now. So this is explicit casting. Now let us check the output. So the data stored is 45. Okay. So char returns like it returns only 1 byte of data. So 1 byte of data it returns. The actual is we have 8 bytes of data. Okay. So it returns just only 1 byte of data. So I simply change this to a short, and I check for the short, right click and build the project. Right click, go for it prints 2 bytes of data. A short gets 2 bytes of data. I just type int. So this is the address. Okay, right click, build the project, and run as C++. So it returns 4 bytes of data. Okay, and type long. Okay, so you could directly pass this value. Right click, build project. Okay, here like LLX. Okay, so now we got the entire value. Okay, we got the entire value. So you have to choose the right data type. Choosing the wrong data type will lead into loss. Okay, so you have to choose the right data type for the pointer variable. Okay, so let me show an example for the operations, like for incrementing and decrementing the pointer variable. Okay, let's go with char. I just type char, and this is. So now let us increment the address, and let us check the value. Like I just take this address. Okay, so just copy and paste here, and right click, build the project. So this is X. Okay, run as local C++ application. So if you check now, so this is the address. Okay, so if you get the address of the data, just if you print this address, I'll also print the address. Okay, print the address address of data. Okay, so this is the address of data. Okay, this is the address of the data which is stored in the pointer variable. So when I try to read this pointer variable by using char type, we got 45. Okay, we are not able to read the other variable. So when I increase the address, it gives 23. Okay, so I just do the same thing. Right click, build the project, and I choose the C++ application. So it shows 45, 23, 11. Okay, so if I try to Okay, so 45, 23, 11. 11. If I change this to int, int, int is 4 bytes, right click. Okay, if you check this address now, it reads this 4 bytes and it reads the other 4 bytes. Okay, so if you check the address here, the offset value is 4 byte 10 4. It increases the address by 4. Okay, and it returns the value as like it reads the 4 bytes and it just returns. So the data type is very, very important on pointer when you deal with the pointer variable. Okay. So this is how it does. Like we have stored this value like ff fe a b c d 11 11 2 3 4 5. Okay. So this is the location. When you increment, you get this value 23. Okay, so if you when you increment this value like 5, you get the value here. So if you give int, like it takes 45, it reads the first it reads the 4 bytes of data. Okay, 4 and the offset. So the next offset is 10 and 14. So if you check the offset address here on the IDE, like 10, the next address is 14. If you by incrementing the pointer one time, the offset value is 14 for int. Okay, for long int, it is the offset value is 8 bytes. Okay, so even if you increment the pointer by 1, so the offset value is 8 bytes for long int. So you have to deal with the data type. So coming to the stdint.h, the importance of stdint.h. As we have seen previously on the data type sessions, like every compiler, every embedded compiler, they have their own width for the data type. Okay, for example, on microchip XC8 compiler for unsigned int, it is 16 bits. Okay, it is 16 bits for unsigned int. Whereas for same thing on ARM-CC compiler, it is 32 bits. Okay, so the size of the data type, it depends upon the compiler. Okay, you have to refer the data sheet. The actual problem on when you write a code is when you write the code is when you write a code on one compiler. For example, if you're writing a code on XC8 compiler, okay, and you finish the project and you want to implement the same thing on the ARM-CC compiler. When you use the same code, it may cause an error because they use different XC8 use a different width for unsigned int, whereas for ARM-CC it uses a different width. Okay, so that may cause a problem. So in order to avoid that, okay, in order to avoid the portability issues, so that your code can run on both the compilers, then you could use this stdin.h header file. Okay? You could use the header file because when you go for the standard, the C90 and C99 standard, it only defines the maximum and the minimum range of the. It does not gives you the standard size for the data type. Okay, it only gives you the maximum. So the compiler, the compiler has have a choice to decide the width according to their performance, according to the target performance. Okay. For an 8-bit microcontroller, if the value of unsigned int is 16-bit, it could give you the maximum performance. Whereas for the 32-bit processor, if it could 32-bit can give you the precision, can give more precision. Okay, so which causes a portability issue. For example, you take this code. Okay, when you use a microchip compiler, like you have unsigned int count equal to 0 and count plus plus, and if count reaches this value, you have to perform a specific task. So this is the code which you have written. When you work on ARM compiler, this code will work perfect. Okay, when you use the same code on this X8 microchip compiler for 8-bit microcontrollers, it won't work because the data type for unsigned int the data type for X8 compiler is 16 bits. It's 2 bytes. Okay, whereas here it is 4 bytes. So the maximum value, the range of 2 bytes is 65535. Okay. So when it reaches 65536, when the value count reaches 65536, the count will be initialized back again to 0. So it will not come to this loop and it will not perform the operation. Whereas when you use a ARM compiler, then the maximum value is this, and it could execute the statement. So the compiler will perform the task. Okay, will perform the task. So the same code will work on ARM-C compiler and it will not work on the microchip compiler, X8 compiler. Okay. In order to avoid this, you have stdint.h, where you have to use alias names for the data type. Okay. It's a standard like header file which will be on the root folder. You could use the same by using this stdint.h, and if you declare the data type by using this stdint.h with the alias name, so like for int8, you have to use int8 underscore t. That's the alias name. Okay, uint8, like unsigned integer 8, you have to use uint8 underscore t. So you just open. So this name is common for all stdint.h. You will find stdint.h on the microchip compiler, X8 compiler. On ARM-CC compiler also you will find this file. Even for STM32 cube will also have this stdint.h file. Okay. So this will give you a standard such a way. So when you use these alias names, and when you develop a code, and this code will have portability, even though if you use different compilers, and if you have a mismatch between the data type, okay, it still works. So that's the advantage of going with this stdint.h. So it also has syntax like uint max underscore t, which defines the largest fixed with unsigned integer possible on that target system. Int max underscore t will take the largest integer possible, okay, signed integer possible on that target system. So stdint.h you could use for most of the, when you go through the embedded C code, you could find out the declaration like this, int8 underscore t. It means they have used the alias name for the data type. So that the code will have portability. Like when you use the same code on some other compilers, the code still works. The code will still work. Okay, so that's the advantage of stdint.h. Okay, with this we come to the end. Like we also have the combo offer. Please do join the PCB design session for those who have purchased the combo courses. Please do join the live session, which is on Zoom platform, 3 hours hackathon on PCB design. On attending that day, like you definitely, like you will be able to design a simple 2-layer board, not a complicated 2-layer board, but you will be able to understand the terminologies of PCB design, and you could still route a two-layer PCB board and generate the jobbers for that. Okay, you will have find the emails on you might have received the emails and the Zoom link. Please do register for the session. Okay, and please attend the hackathon and learn PCB design on 3 hours. Okay, so the combo offer, like you could get the combo offer. We also have the job assistance course where we cover up like various microcontrollers like 851 architecture, PIC architecture, ARM7 architecture, LPC 4088 architecture, Node MCU architecture for each for 5 days, and which has 5+ projects. And you have IoT masterclass where we have covered up the Amazon Web Service, Microsoft Azure platform, and ThinkSpeak platform, and nearly 5+ projects we have covered up on IoT masterclass. Okay. And we also, all these value are available just for 999 rupees. We also have a PCB design masterclass for you, where you could design your own development board, 8051 board, and you could attend the hackathon sessions. You could get the invite. You will get the invite for the community. Please do join the community. please check an email for Warriors Way. Those who have purchased, please check the invite for Warriors Way. Definitely you might receive the invite, and please do join that invite. Okay, so thank you so much for your time. So we also have the job assistance program, which will cost you around 799 rupees. Like around like 30, like 20 plus courses are there, like AI masterclass, data analytics, machine learning, deep learning, Python, computer vision, art programming, ESD, embedded system design, and Internet of Things, FPGA for 27 days, and the PCB design, Arduino masterclass, MATLAB masterclass, and Raspberry Pi masterclass. Apart from this, you also have soft skill training like LinkedIn mastery, interview skills, and resume building. So all this available for 799 rupees. The price will increase for 9,999 within this month. So if you want to avail, so the validity will for 2 years. You will have 2 years validity. Okay, so if you would like to avail this offer, you could avail this offer. It is a limited period of time. So thank you so much for your time, and please do be active on the Facebook group, and I will release you the assignment probably today or tomorrow. Okay, so please do submit the assignments and win the pen drive. Thank you so much for your time. See you on the next session tomorrow. Until then, bye bye. Take care.